Amplitude. The amplitude is the modulus of b. So we have our graphs in the form of y equals a plus b sine of cx, or y equals a plus b cos of cx. So the b is whatever is stuck on in front of the sine or the cos. So the rule is the amplitude of a sine or cosine graph is the modulus of b, i.e. the modulus of b. So the positive value of whatever b is. For example, the amplitude of y equals minus cos of x is the modulus of minus 3, which is positive 3. So the transformation. The modulus of b, or modulus of b, gives the factor of the vertical dilation, which is the stretch or shrink parallel to the y-axis. If the modulus of b is greater than 1, the graph is stretched, while if the modulus of b is less than 1, the graph is shrunk. So the diagram opposite shows the curves y equals sine of x and y equals 2 sine of x on the same graph. So the dotted line is y equals sine of x, so the dotted blue line is the graph y equals sine of x. And the orange line, so the solid line, is the graph of y equals 2 sine of x. So the orange line is the graph of y equals 2 sine of x. So we can see it goes up as far as 2 on the y-axis and down as far as minus 2 on the y-axis. So the diagram opposite shows the curves of y equals sine of x and y equals 2 sine of x on the same graph. Note that the curve y equals 2 sine of x is the curve of y equals sine of x stretched by a factor of 2 parallel to the y-axis. So it's been stretched upwards and downwards. Like the other examples given above or in other videos, we can construct the graph of y equals 2 sine of x by forming a table of values, if required. A table of values for y equals 2 sine of x is given below, for x values greater than minus 360 degrees, but less than positive 360 degrees. So these are our x values, these are our sine of x values, and these are our y equals 2 sine of x values. So basically just take the sine of x value and multiply it by 2. 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is 0, minus 1 times 2 is minus 2, and so on. So our green curve is the graph of y equals sine of x. Notice that its maximum point is 1 and its minimum point is minus 1. And its midway line is the x-axis. And our red curve is the curve of y equals 3 sine of x. So it's been stretched upwards as far as 3 on the y-axis and downwards as far as minus 3 on the y-axis. So our green curve again is the general graph of y equals sine of x. Goes up as far as 1 on the y-axis, down as far as minus 1 on the y-axis. And the red curve is the graph of y equals 4 sine of x. So it stretches up as far as 4 on the y-axis and down as far as minus 4 on the y-axis. But note that the midway line is still the same. The midway line is still the x-axis. So the green line is the curve of y equals cos of x, and the red line is the curve of y equals 2 cos of x. So it has been stretched up as far as 2 on the y-axis and down as far as minus 2 on the y-axis. So note that it still intersects the x-axis at the same points. So the green line, again, is the general curve of y equals cos of x, and the red line is the curve of y equals 3 cos of x. So it's been stretched up as far as 3 on the y-axis and down as far as minus 3 on the y-axis. Still has the same midway line, which is the x-axis, and it still crosses the x-axis at the same points. And again, the green curve is the graph of y equals cos of x, and the red curve now is the graph of y equals 4 cos of x. So the curve has been stretched up as far as 4 on the y-axis and down as far as minus 4 on the y-axis. Again, we have the same midway line, which in this case is the x-axis, and it crosses the x-axis at the same points.